Hey folks, how are you doing today? Hope you're doing well. We'll just wait for the other folks to arrive. Who just came in? Hi, Felicity. Welcome. Someone else is here. Can you sign in so that I know who you are so I can take attendance? Hey, Sadrina. We'll start in like 3 or 4 minutes.
Let me see who else. Hey, Chu. Welcome. Go ahead and do the attendance right now. Cool. Hi, Lizeth. Welcome. Let me see. Hi, Jackson. Welcome. Whoever got here, just go ahead and sign in. Oh, someone left. If you guys are all right, let's give it 5 minutes just in case there's some technical difficulties. So far, no one's texted, so we should be good. Hi, Yumang. I will. Give me a minute. It's very, very simple, Felicity. An octave is when you return to the same note. So if you start on C and you end on C, C is the octave. If the first note you play is a G and you play the notes of the scale and you end on G, that G is an octave. You can do it with your fingers. Ready? Oh. Octave means 8. So here we go. We start on C. C, D, E. What am I doing? C, D. Let's do it this way. Eight strings. Let's do it this way. C, D. Oh, my Lord. Sorry. C, D, E, F, G, A, B, C. Do it again. We're starting on C. C, D, E, F, G, A, B, C. 8 fingers. Therefore, it's an octave. So it just means when you play a scale, the 8th note of the scale is always the same one. We start on D, D, E, F, G, A, B, C, D. We get back to the same note. That's an octave. But I'm going to talk more about it in a little bit, about more in depth. All right? Let's give it 2 more minutes and then we'll start. Does anybody have any contact information? Hi, Raina. How are you? All right, so I guess that makes sense, Felicity. Good. Does anybody have any contact information for some of the other folks, like Ruby or Luis, particularly Luis? Billy was here last time. Caitlin was here last time. Christopher was here last time. So those folks have all been able to get in. Jesse was here. Himanshu Kumar was here. Brian was not. So I just want to make sure somehow. I was just wondering if anybody has contact information for these other folks. And Christopher was here last time. Nakia, she wasn't here last time. So I wonder if she knows what we're doing. Yeah, could you text him so that he jumps in? I would really appreciate it. Thank you, Karina. Hold on, I'm reaching out to another person. Let me see if I can get them. Thank you. Cool. Who else is here? Hey, Billy, how are you? All right. Okay, Christopher, Caitlin, Jesse. Still waiting for those other folks. They were here the other night, so good. Thank you, Karina. Let me see. Good. So hopefully he can get in. We know that those other folks can get in. There's about 5 more people who were here the other night, and they were able to get in then, so they should be able to get in now. So we'll wait a minute or two, okay? Hey, Luis, welcome. Welcome. This is Philip. All right, well, let's get started. Okay, we have a lot to cover tonight, and it's complicated. So I'm going to keep an eye on this screen, and I'm going to, if you have difficulties, you need to let me know right away, because it's going to come fast and furious tonight, and it's a little complicated. All right, tonight's kind of we're getting to the hard part here. All right, so, and I'm just going to straight up lecture. Normally, like, if everybody has their packet, you get out your packets, right? Normally, tonight would be that last night where we go through everything, and you would do the assignment yourself. It's kind of an activity that you do in groups, but I'm just going to do it for you. So I'll just lecture straight up, which is boring, but that's what I'll do. All right. So if everybody can go to page 3. Okay. We're going to do page 3 and page 4 tonight. And then we'll review everything on Monday. Okay. So what we have is this. Okay. So let's review just real quick how a scale is made. So a scale. Okay. All Western music is based on the C scale. Okay. So we write it in C, D, E, F, G, A, B, C. So that's step 1. Write the letters. Okay. Now, step 2 is we look at our chart. We look at our keyboard. Let's move this up. There's our keyboard. C to D, just to remind everybody, every time you move to another key, another button, it equals 1/2. So this to C sharp is 1/2. C sharp to D is 1/2. So C to D is 1/2 plus 1/2, which is a whole. Okay. D to D sharp is 1/2. D sharp to E is 1/2. 1/2 plus 1/2 is a whole. If you notice, there's no dark one between E and F. There's no black key. Therefore, E to F is just one key. So that's 1/2. Okay. I think we can continue now. F to G is obviously a whole. G to A is obviously a whole. A to B is obviously a whole. And B to C, because we're just moving one key, that's 1/2. Okay. This should all be review. Okay. So the major scale of Western music has a pattern of okay, that's our pattern. Good. Now we have a second scale. Okay. We have the minor scale. I think I covered this the other night. Someone remind me, did I cover this the other night on Monday night? Pretty sure I did, but remind me, please. Someone? Thank you, Felicity. All right, so our minor scale has a different pattern. That pattern is 1, 1 half, 1 1, 1 half, 1 1. That's the pattern for the minor scale right here. So now let's do it again. Okay. We're going to make a C minor scale. If you notice that little m, that means minor. C major is a big M. So you write major with a big M, you write minor with a small m. Don't worry about it. So first step is we write the letters. Okay. Now we put in our amounts. 1, 1 half, 1 1, 1 half, 1 1. All right. So now we're going to make changes. So C to D, as everyone can see, when we go from C to D, that's 1 half plus 1 half, that's a whole. We have a whole. Very good. Now from D, we need to go up 1 half. So 1 half above D is this one right here. It has to be an E because we never change the letters, as I've said many, many, many times. Once you write those letters down, you don't erase them. They're what they are. So this has to be an E. So this black note below the E is called an E flat. Okay? All right. That seems to be giving some folks some trouble. What's a D sharp? What's an E flat? When you write the scale, you write the letters down. You never change the letters. You never erase them. They are what they are. Now we can add flats and sharps. This has to be an E. It can't be a D. So it's not a D sharp. It has to be an E flat. It has to be because we have an E to deal with. So our next number is an F, and we need one whole tone. Our next letter is an F. So we go 1, 2. So that's 1 half plus 1 half is a whole. So that's good. F to G is a whole. That's good. Now we have a problem. G to A needs to be only a half. So we go up a half, which is right there. And this black key, it has to be an A because we've written an A. That doesn't change. So this black key is an A flat. Okay. Now A flat to B, we need a whole tone. So we go from here, we go 1 half plus 1 half is a whole tone. That has to be a B. It's on the black note, so that's a B flat, whole tone. So this is our scale if we're playing the minor scale. Yeah, it was when we did the chords. I gave you major chords and minor chords. I'm just reviewing now before we get to the hard part. Okay, is everybody clear? Clear? Help me out here. Are we good? Because I'm going to move forward. I just needed to review. I just want to make sure that everybody's good. Excellent, excellent. Thank you, everybody. So now just to, Lizeth reminded us about chords. So chords are straight up. You take the first, the third, and the fifth. So a C major chord would be C, E, G. 1, 2, 3, 1. Oops, my bad. Let me get this sheet back on here. So to make a C major chord, it would be 1, 3, 5. 1, 2, 3, 4, 5. So C, D, E, F, G. That would be a C major chord right there. Now, once we make the scale, we do the exact same thing down here. 1, 2, 3. So we start with the 1, 2, 3. Okay. 4, 5. And that's a C minor chord. Good. We lost somebody. Who do we lose? Oh, well. Hey, Karina, are you communicating with Luis? Has he gotten in? Oh, yes, he did get in. My bad. I forgot. Okay. All right. Now the hard part. And I'm going to tell a little story. Some of you have already heard the story. So, our friend Pythagoras. Okay, our friend Pythagoras. You all might know him for the Pythagorean theorem, which is this. The Pythagorean theorem is this. You have a triangle, and you say that the square on this side plus the square on that side equals the square on this side. So a squared plus b squared equals c squared. Okay, that's the Pythagorean theorem. All right? But Pythagoras was also known for music. He basically set up the mathematical underpinnings of the Western musical system. Hi, Ruby. Welcome. Welcome. You got here just in time. All right, let me do your attendance and then so I don't forget. Excellent. All right. Okay, so Pythagoras was also known for setting up our Western musical system. He lived about 700 BC. Okay, and this is what happened. Pythagoras was walking down the street, and he walked past a blacksmith shop. And he heard the blacksmiths banging on metal. And what he noticed was that when some of the blacksmiths hit their metal at the same time, it sounded really good. When some of them hit the metal at the same time, it sounded really bad. And so he had a question, and his question was, why does it sound good sometimes and not sound good other times? So what Pythagoras did was he was smart. He said, let's weigh their hammers, their mallets that they're beating metal with, right? And what he discovered was this. If the one hammer was twice as big as the other hammer in a ratio of 1:2, precisely, this was the most beautiful. Okay? So when someone who has a hammer twice the weight of somebody else, and when they hit it at the same time, it was the most beautiful. Then he did some more experiments, and he found that if the hammers were in the ratio of 2:3, so this one was 3 pounds and this one was 2 pounds, right? It was the second most beautiful. Okay. Then what he found was if they were in this ratio, okay? So what he found was that music, beautiful music works in these ratios, in these relationships. So it's not just for weights. Here's the other thing. If I take a string, okay, and I cut the string in half right here, so this is equal to 2, and that's 1/2 2, which is 1, okay? I get the exact same thing. I get the most beautiful sound. And Felicity, this is called an octave. So if we, on our keyboard, when we go from C to C, what's actually happening is that this whole thing right here is a C. This right here is C prime. So it's the next highest C. So this is C, this is C prime. The whole thing is C. When we cut it in half, we get C prime, and that is an octave. Okay? So the idea is when you cut it in half, you get back to the first note. Does everybody understand? Give me a yes or a no, so we're good. So I know that you're with me. Thank you, Karina. Excellent, excellent. Thank you, everybody. All right. Hey, Lizeth, do you have a follow-up question then? Give me your follow-up question so I can help be clear, because we're going to go from this right here is a nice walk down the street, and pretty soon we're going to be on a super highway going really fast. So I want to make sure that we know how to walk first. So help me out, Lizeth. What part is troubling you? Do you have any idea, or is it just kind of fuzzy? Basically, if we want to go from C to C, we just cut the string in half. By the way, it works the same way with a flute. You know, if you play the flute and it has holes on it like this, that is correct. If it's half the string, it's the next highest C. So let me see if I can sing it. Don't laugh at me. Ah, 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 ah. That would be the octave. Ah, ah. There it is. Ah, ah. So what I did was I just cut my vocal cord in half. And so I got the next highest note. Okay. Works the same thing. If you cut this in half, if you play the flute, so this is the flute, and you play the flute, right? Let's say the flute is in F. If you cut it in half right here, it's F prime. So when you cover the holes to block the air, it becomes F prime. So it's half to half. All right? Yeah, thanks, Rena. Yeah. There was a day I used to sing, but that doesn't work anymore. All right. Is everybody good? All right. Now I'm going to turn the page over. Hopefully you've all been taking notes. And I'd suggest you need to take notes because it's going to go fast and furious in a second. Now, if I take that same string and we put it in the ratio of 2 to 3, okay? What that means is I take the string and I divide it into 3 parts, okay? I put my finger right there and block it so that this is 2 and this is 3. Okay, so it's the same string. I just break it into 3 parts. This gives us a fifth. Oops. Okay. So what that means is that if this is a C, right? Hold on, let me focus it again. Sorry about that. There we go. If this is a C, this note right here will be a C, D, E, F, G. A fifth will be a G. Okay? So if we're in the ratio of 2 to 3, the C, if this string is at the note of C, when we cut it at 2/3, we get a G. We get the fifth. What we get is that the camera's out of focus. There we go, better. Do we have any questions? So the way you cut the string gives you different notes. And let's do the last one. If we have a ratio of 3 to 4, okay, which was the next one, here we go. Here's our string. We get a fourth. So we cut our string into 4 parts. Okay. We put our finger right there. This whole thing is 4 parts. We cut it into 3. Okay. If the string is a C, Okay, then we have, let me see, C, D, E, F. This right here will be an F. Yes, this is what we did yesterday, Idalina. All right. Is there anybody who has any question about how this works? In other words, for anyone who's ever played a guitar, you notice there are frets and you put your fingers in certain places. Where you put your fingers gives you a different note because the maker of the guitar has actually measured it so that when you put your finger at the halfway mark, so that when you put your finger at a certain place, you're cutting the string in half and you had a C on the string and then you play the next higher C over. Okay? And he's measured his guitar so that if the string is a C and you put your finger at this fret, you'll play a G. Or if the string is a C and you put your finger here, you'll play an F. So they're all this mathematics. And this is what a maker of instruments does. And it doesn't matter whether it's a guitar or a flute or a pipe or a saxophone or a trombone or a drum. All of them tune in exactly the same way. They tune to these ratios. All right? Help me out now. Does everybody understand where we are? Let me know if you understand, please. And if not, give me another question so we can make sure it's clear. The next part's kind of tricky. Excellent. Thank you, folks. What about everybody else? Are we good? All right. Thank you, everybody. Thank you. Here we go. Go to your next page. Okay, and that's going to be page homework 3. So I'm going to try to do this on the screen 2 ways. Okay? Do we have all that on the screen? Let's see. Hold on, I'm going to go up a little bit. Maybe I can get more on the screen. All right. Is that still big enough for everybody? All right. Now, let's look. All right, Felicity, I'll go over it one more time. What Pythagoras learned was this. Okay? If I cut a string in half, I go to the same note, C to C. On our keyboard, C to C, that means we've cut the string in half. Good? All right. If we go, on the other hand, if we cut the string in the ratio of 2 to 3, okay, then we get a fifth. So if I start on C, if the string is on C, and I cut it in 2 to 3, I get a fifth. So that's 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. I'm at a fifth. Okay, so if I cut it here, I get a fifth. All right? It's how we actually get that note G, is we cut the string in 2/3. And that gives us that note. Okay? So just on the side, I've been teaching you all these things like here are the rules, etc., etc. If you cut a string a certain way, you get a certain sound. And then the scale is built based on the math of that. So it's not random. I mean, it is exactly the way it works. And my guess is that if you lived on the planet Hoobie-Boo, your music would be tuned the same way. Yunming, I don't understand your question. How to get the key? I don't understand your question. The key is named by the first note you start on. Whatever scale you're in, that's the key. Is that what you meant? Okay. Let's go back to our C scale. Okay, there's our C scale. The fifth of the C scale, we're going to count 5. 1, 2, 3, 4, 5. We land on G. Let's try it again. 1, 2, 3, 4, 5. G is the fifth degree of the scale. Yunming, is that making sense? That's how we get to G. Good, very good. Another way to look at it is this. Now we looked at the letters, and that got us to G. Now let's look at the tones. At G, we have 1 plus 1 plus 1/2 plus 1 is 3.5. And so that equals 3 1/2 tones. Okay? Let's do it again. 1, 2, 3, 4, 5. Our fifth gets us to G. Now we count the tones. 1, 2.5, 3.5. G is 3 1/2 tones, and it always will be. So the fifth will always be 3.5 tones, no matter where you start. Good? All right, good. Now, here we go. Let's go to our worksheet. We're going to put all this together. So, if we start on C, okay? There's no tones because we're just starting right here at C. We haven't made an interval. We haven't gone anywhere. So we have 0 tones. The interval is the tonic. That means the first. Okay, that's just another term for the first. The ratio is 1 to 1. So in other words, here's our string. It's a C string, and we play the whole string. We don't cut it anywhere. Here it is. It's 1 to 1, C, and we just play it and we don't cut it. Okay. Now let's go to the fifth since I just went over it. Okay, here we go. I just went over it. So the fifth, which is the interval, C, D, E, F, G. That's the fifth. It's the ratio of, you know what, some people do it one way, some people do it the other way, and I should just fix this worksheet because I prefer to do it this way. Okay, so this is a ratio of 2 to 3. That's what Pythagoras discovered. That when you cut the string in 2/3, you get this ratio. Okay, everybody? And like I just showed you, a fifth is 3 1/2 tones. So let's do it. We start on C, and we're going to count how many tones between C and G. Okay? That's 1/2 plus 1/2 is 1 whole. Plus 1/2 is 1 1/2. Plus 1/2 is 2. 2 1/2. 3. 3 1/2. So 3 1/2 tones. Okay? Let me bring it down a little bit. You all should have page 3 out, right? So 3 1/2 tones gives us the fifth, and the strings will be in the ratio of 2 to 3. So we have 3 things going on. Okay? The one is we're on the 5th degree of the scale. If we cut a string to get to that note, we cut it in 2/3. And the total tones on our scale are 3 1/2 tones. Let me know that you're good. We have 3 things going on. Is everybody good about all 3? Give me a yes or a no. By the way, this is what instrument makers do. They have to know all this math inside out. Good. Excellent. So folks got it. Thank you very much, everybody. Okay. Karina, what we just went over your scale, right? So if I start on C and I go to G, that's a fifth, right? And use your fingers. Let me see. C, D, E, F, G. That's 5 fingers. So therefore it's a fifth. Always start with C. Start with your first note. C, D, E, F, G. 5 fingers, it's a fifth. Okay? When we count the tones, the total number of tones between our starting C and the fifth above, we're going to count the number of tones. 1. So each time we move to the next key, it's 1/2. Do you remember? We talked about that a lot yesterday. So every time you go to the next key, it's 1/2. 1/2 plus 1/2 is 1. Plus 1/2 is 1.5. Plus 1/2 is 2. Plus 1/2 is 2.5. Plus 1/2 is 3. Plus 1/2 is 3 1/2. So in order to go up the scale, it's 3 1/2 tones. The fifth of the scale is 3 1/2 tones. And if we want to cut a string, so if we have a string that's in C and we want to make the G sound, then we cut the string in 2/3 like I demonstrated before. Okay, so we have 3 things going on at the same time. We have the number of tones on the scale, we have the degree of the scale, which is the fifth, and we have the ratio of the string. This one is in the real world. Right here. That's actually what happens. Right? You hit with a hammer in 2/3. Your drum, one drum is 2/3 bigger than the other one. Lizeth, that's a great question. It's what I was just explaining. This has no philosophy attached at all. This is what happens in the real world. So all of this stuff, all of this up here, okay, that's what math has done to it. This is what actually happens in the real world. So if I cut a string in 2/3, I get a note that is pleasant. I start with C, I cut a string in 2/3, I get a note that's very pleasant. Okay, I start with C, I cut it in half. That's a ratio of 1 to 2, it's 1/2. This can also be written as like this, but that confuses people, so I don't write it that way. So this is the most pleasant sound of all. And all of world's music works on this, and on this, and on this. Every single culture in the world plays those ratios and those intervals. That's just how it works in the real world. That is how actually nature does it. Does that make sense, Lizeth? Help me out, Lizeth. Does that make sense? Okay, it's just that's what happens in the real world. So it's not, this is like something there's nothing really to talk about. That's like saying, why does the moon rise in the east? It just does, right? You know, that's the way it works. Well, there's no more examples. I'm giving it to you. This is the way the world works. This is like saying, yep, the moon rises in the east. This is like saying the sun rises in the east. This is like saying the moon changes during during a month. It's just the way the world works. It's physics, period. Done. There's nothing to be done. That is how life works in the physical world. If you freeze water, it gets hard. That's how the physics works. Right? So these are exactly how it works in the real world. This is the math that comes from that. And we're about to go here right now. Ah, great. Not chord. Not chord. Don't say chord, but you're absolutely correct. And you know what, Lizeth? That's where we're going right now. That's what I'm going to show you. Okay? So you know the ratios of each interval, not chord, but interval. Okay? The chord is 3 notes put together because they sound good together. But the interval is what we're really looking at. Okay. So are we ready? We're going to do some hardcore math now. Let me get it focused. Give it a second till it focuses. Okay, does everybody have their worksheet in front of them? Because I'm going to do this without the worksheet. Let me see if I can get it to focus again. Okay, let me do this. Sorry, I did that last night. I was having the same problem last night. Give it a second. Let me try this. Good. All right, here we go. Okay, take notes. All right, because you're going to have to do some math now. Here are our rules. Okay, everybody with me? When you add ratios, you multiply. When you subtract ratios, you divide. That's the rules. Good? So I'm going to give you an example. If you notice, everybody watch please, from C to D, the total tones is 1. We don't know what the ratio is. So how do we figure out that ratio? That's our problem. So my question to you is this. We know the ratio of this one, and we know the ratio of this one. What could we do with 3 1/2 and 2 1/2 to get a 1? Someone type it in, please. What do we do? What operation do we do with 3 1/2 and 2 1/2 that'll give us a 1 when we're finished? What do we do? So go ahead and type it in. We subtract. Very good. We subtract. Very, very good. Because 3 1/2 minus 2 1/2, okay? 3 1/2 minus 2 1/2 equals 1. See that 1 right there? We want to figure out what the ratio is for that 1. Now, when you subtract ratios, you divide. Everybody good? So the ratio of 3 1/2 is 2 to 3. And we're going to divide that by 3 to 4. Okay, it's going to be 2 to 3 minus 3 to 4. And the rule is that when you subtract ratios, you divide. Okay, so we have 2 to 3 over 3 to 4. That's this minus this. That becomes, remember the rule is you multiply by the reciprocal. So that becomes 2 times 4 is 8. 3 times 3 is 9. Therefore, if we go back to our worksheet right here, we know that the interval right here is 8 to 9. What this means is this. If I have a string, and the string is in C, the string is in the note of C, okay? And I cut it into 9 parts, okay? And I put my finger right here so that this is 8/9. This note will be a D. If we start on C and we go to D, that means we've cut the string and we've cut the string in 9 parts and we've played 8 of them. Or if you don't want the string, it could be a pipe, a flute, a drum, doesn't matter. Anything in the ratio of 8 to 9 will give you the next note in the scale. Good, good. So now here's my assignment for you. I want to find out what the ratio of a third is from C to E. How many tones is that? Here's my hint. How many tones is that? And how, using one of these 3 things, what can you do to get from that to 2? And then I think you can do it. So why don't you try it out, okay? I'll give you a minute or 2. Someone type in what you would do to get the interval that is 2 whole tones. What do you think you could do? Yes, I think you kind of have the idea. You would add this ratio, right? C to D gives you 8 to 9, and that's 1, right? So 1 plus 1 would be 2. I think you had the right idea, Lizeth. So what do you do when you add ratios? Go ahead and do it. It's in your notes, okay? And when you're done, go ahead and tell me what you get. We're adding the ratio of 8 to 9 plus the ratio of 8 to 9. And when we add ratios, we multiply. So what do you get when you multiply those 2? Someone have an answer? Or if you don't get it, right, I'm lost. Either way, so I know where we are. Okay, all right. Okay. Can everybody see that our interval right here is 1 tone, correct? What do we do with a 1 to get to 2? How about this? Does that work? 1 plus 1 equals 2. So this one plus itself will give us a total tone, 2 total tones. Good? Now, when we add ratios, we multiply. Okay? So the ratio of one tone is 8 to 9. One tone plus one tone will be 8 to 9, which is the ratio, times 8 to 9, which is 64 over 81. Okay. Is that clear, folks? Yunmeng, you have to go back to your notes. We already got it. Okay, we did that like 10 minutes ago. So you need to look at your notes, or you can rewatch the video for how we got 8/9. Okay? We're running a little short on time. Sorry about that. All right? So the idea is that we can manipulate these numbers, and then we're going to multiply and divide. Okay? To do it. So what do you think you could do to go from 3 1/2 to 4 1/2? Someone type in what you could do to go from 3 1/2 to 4 1/2. Just type it in. What are we going to add? Very, very good, Eilina. Very, very good. So we're going to add 1. Excellent. Thank you. So to go from 3 1/2 to 4 1/2, we're going to add 1. There's our 1 right here. Here's our 3 1/2. So we have 2/3. That's the 3 1/2, right? We're going to add 1. Good. And when we add, we multiply. So 2 times 8 is 16. 3 times 9 is 27. Therefore, the string length ratio will be 16 over 27, right there. How are we doing? Is it making some sense, folks? Give me a yes or a no. Awesome. Super. Okay, now, how are we going to get, I want you to do this yourselves and then write down the answer. How are we going to get from 4 1/2 to 5 1/2? So you all do that yourselves, okay? While you guys do that, I'm going to talk to Felicity for a bit. All right, Felicity, you said you weren't understanding. So the steps are this. You start with the tones up top. You see the tones? Right? And then what you can do is you can add and subtract them to get the other tones. So right here, we had a 1, and we added 1 plus 1 to get 2. Okay? So 1 plus 1 is 2. Now, when you add ratios, you multiply. Therefore, it was 8/9. 8/9. Oops, my bad. 8/9 times 8/9. 1 is 8/9. That's 1. 1 is 8/9. So when we add 1 plus 1 in tones, we multiply the ratios. So we have 1 plus 1 is the same as 8/9 times 8/9, because for ratios we multiply. 8 times 8 is 64. 9 times 9 is 81. And now if we cut our string into 81 parts and we play 64 of them, then we get a third from C to E. That will give us that note. So Felicity, is that making more sense now? And you other folks, you should have your answer by now. What's your answer? Go ahead and type it in. Absolutely. You all did a great job. You did a great job. Very, very good. Excellent. All right. Hey, someone else came in. Who else came in? Can you sign in? We were at 14 and now we're at 15. So who else joined? Oh, I know who it was. I gotcha. All right. Okay, so this becomes 128 over 243. We have all of our ratios. Okay. Now let's look at this. So this would be, to get there, what we did is we went 4 1/2 plus 1 equals 5 1/2. Okay. 4 1/2 is 16 over 27. 1 is 8 over 9. Okay. We multiply the 2 and we get 128 over 243. Now, what this means in the real world, it's not just a number. So I want to be clear, and I want to go back to Lizette's question because it's a really good question. This actually, the whole point of this right here is that this is how it works in the real world. In the real world, if we take a string, okay, and it's tuned to C, this string is a C, and we cut this string into 243 parts, and we cut it off at 128 parts so that this is 128, okay? This will be a B. So if the string was a C and we cut off 128 parts, this is a B. Oh, got it. All right, is everybody clear how that works? If not, let me know. Just give me a yes that you got it. Good. Good, Sadrina. Excellent. Excellent, excellent. I'm glad. All right. Now, I want you to try to do this assignment down here. Look at number 2. Find the interval of a semitone. That's a half tone. That is for B to C or from F to F sharp. How would you do that? So is there some way that you can use these ratios up here to get a 1/2? You can either add or subtract. It looks like you're going to have to subtract, but I want you to figure that out and do the math and then give me your answer, okay? So I'll give you a minute or two to do that. When you're done, just go ahead and type it in. Sorry, let me put this back up for you. My bad. There you go. So figure out a way that you can add or subtract to get a half. And remember, subtraction is division. Where's my phone? There it is. Okay, do we have it yet? Or type in what you think your strategy would be to do it. Beautiful, Lizette. That's exactly correct. There we go. Ruby, good job. Subtracting C from B, yes, that would work. Though that's the hard way to go. I think you made a math error there, Ruby, but oh no, F from E. Yeah, you guys got it right. Kira, you got it right. Ruby, you got it right. Good. Let me see. Subtracting C from B, that would work. We could do that in a second, but I think you just made a small math error. Okay. And Lizeth, you're correct. So go ahead and do that. All right, looks like a lot of you got it, so I'm going to move on a little bit. So in our chart, if you notice, F minus E is 2.5 minus 2, and that will give us a half. The other way is you can say 6 minus 5.5. That will also give us a half, right? Let's do, no, Karina, you got the wrong one. You got the same as Lizeth there. Not Lizeth, my bad. Sadrina. So let's do that. I don't know what happened. I think I know what happened, but let's try it. Okay? So 6 is 1/2. Okay? So C is 6 tones. Good? Everybody good? B is 5 1/2 tones. So 6 minus 5, oops, my bad, sorry. 6 minus 5 1/2 equals 1/2, which is what we're trying to find. Okay? So the 6 tones, the ratio is 1/2. The 5.5 tones, the ratio is 128 over 243. Okay? So now this means division. So then we have 1/2 divided by, because that's our division, 128 over 243. So we multiply by the reciprocal. Multiply by the reciprocal. Like that, okay? Those cancel, and we have this. 1/2 times 243 over 128. And our answer is 243 over 256. Are we good, Karina? You got it? Sadrina, you got it? Yeah, that's my bad. I'm sorry about that. If you notice, I scratched it out and I put 1 to 2. And you're correct. I'm going to go change this worksheet this year. All right. So, on Monday, let's finish this up. Let's wrap it up. On Monday, someone joined us. Who just joined us? We're now up to 16. Yeah, I'll show it from F to E, sure. All right. And then let's talk about Monday and next Wednesday. All right. So F to E is this. And Lizeth, it would be better. My suggestion would be, rather than thinking of it like F to E, think about it like from the 4th to the 3rd. Okay, from the 4th to the 3rd, because we might not start on a C. We can start on any node and the same thing happens. All right, so F, so we have a 4th minus a 3rd. That would be 2 1/2 minus 2. Okay, which would be 3 to 4, that's 3/4, divided by 64 over 81. All right, because subtraction, when you work with ratios, is division. So this becomes 3 over 4 divided by 64 over 81, like that. Okay? So now we multiply by the reciprocal. Those cancel. And then we get 3 times 81, which is 243. 4 times 64, which is 256. Does that work, Lizeth? Excellent, excellent. So that's how you do it. Are we all clear? Yeah? So to repeat, our steps. Step 1, okay? So step 1 is to add or subtract the tones So right here, what we did was we add or subtracted these things up here, right, to get to our target. Okay. Step 2 is to add or subtract ratios that correspond to those tones. And then we're done. That's it. It's just those 2 steps. So step 1, just to repeat, step 1 is we add or subtract these numbers to get what we want. And then step 2 is we use the ratios and we multiply or divide, and then we get our answers. Good? All right. So on Monday, we're going to have a big activity and I'll go ahead and show it to you. And then on Wednesday of next week, we'll have our quiz. Okay. That's it. Should be straightforward. The quiz will be very simple. For the quiz, I'm asking you to just make scales. All right, I have one other story for you. Don't go, because I have one more story. Okay? Our friend Pythagoras, the way Pythagoras died was kind of funny or bizarre. So Pythagoras, okay, not only did he do mathematics, he was a religious leader. And he had a cult of folks, and the belief was that his belief was that the world was made of numbers and that everything could be described by perfect whole numbers. So he had a whole religious cult, and they were vegetarians. They didn't worship animals. They didn't sacrifice animals. They didn't worship the Greek gods. And consequently, they were heretics. And in the rest of the Greek world, the religion at that time was that you worshiped the gods and you sacrificed animals. And the Pythagoreans didn't do it. And so they were considered heretics, and they weren't liked anywhere they went. So the way Pythagoras died, but Pythagoras had a funny quirk. Okay? Pythagoras thought that beans were evil. He thought that they were bad, and for whatever reason, that they were evil. And we got out of focus. Let's see if I can focus again. So he thought that beans were evil. All right. And so then this is how Mr. Pythagoras died. So they lived, so in Italy, the country of Italy has a boot down at the bottom. It kind of looks like this. And then right here, there was a town called Cremona. And that's where Pythagoras lived. All right. Now, the people of Cremona hated Pythagoras, and they hated the Pythagoreans because they were heretics. They didn't worship the gods. They were vegetarian. They treated women equally. All those things were terrible. So they set out to kill them. So they wanted to kill Pythagoras because he was this horrible person. And so here's how it worked. This was the ocean right here, because Cremona was on the ocean. Okay. And there was a road right here. Okay. And what happened is, and right here was a field of beans. Okay. There was a boat on the ocean right here that was coming to save Pythagoras. The Pythagoreans were running up the road. This is the Pythagoreans. I'll give it a P. The people from Cremona were chasing them. Okay. All Pythagoras had to do was to cross this way to the ocean, across a field of beans, and he could have gotten on the boat and sailed to safety. But he was so afraid of beans. He hated beans so much that he refused to cross the field. And so the Cremonans caught up to him and they killed him. And that's how Pythagoras died. So he died because he was afraid of beans. And that was the death of Pythagoras. And we have that story from old texts. We have that story from 3 or 4 people that's what happened. He just refused to touch the beans because the beans were evil and they would make him evil. So that was the idea. Or make him dirty or defiled or not good. So that's what happened. There's my story. There's my bedtime story for everybody. The death of Pythagoras. All right? Are we all good? And that's it. We're done for the day. Do you have any further questions? Anybody? Oh, I'm glad you liked my story. No, your homework I kind of did for you. We're going to turn in the packets on Wednesday. Okay, so on the day of the test, which is Wednesday, you'll turn in the packets. That's a good question, Luis. All right? And I already did your homework for you. Your homework was this. There it is. That was your homework, and we already did it. All right? This we're going to do on Monday. Oh, my Lord, how did we get that idea? No, you will not be at school on Wednesday. You'll turn it into me. I'm figuring that out. The other class is turning in their packet on tomorrow. And they're going to turn it into my other email. Okay? So no, you do not show up on Wednesday. You'll take a picture of it or scan it and turn it in as an email. You all can write this down, by the way. So take a picture or scan it. This is my email that our streaming goes to. Okay, so write that down. prof.hornescc@gmail.com. So that's the Gmail account I created for this online course stuff. Okay? So next Thursday, or my bad, next Wednesday when you take the test, you'll have to turn in your homework either by a photograph or a scan and just turn it into this email, okay? And then I'll give you credit. I would suggest that homework math 4, I think it would be really, really valuable if you all try to do this by yourselves. Spend an hour or a half hour and try to do this by yourselves, okay? It's tricky and complicated, and then I can go over it on Monday. So let's say your homework, don't worry about it. I'll tell you about the quiz on Monday. Don't worry about it. Okay? It's not difficult. Why don't you do this for your homework? Okay, do number 4. All right? Everybody good? Any questions? Any questions? All right, then you're welcome to log out. Go ahead and log out. We are done. You're welcome. You're welcome. Thank you, Raina. You guys have a really good weekend. I'll tell you one more thing. This, when you do this, many Pythagoreans committed suicide. They did your homework on number 4. And after they did this, they committed suicide. So be careful. And I'll explain that on Monday. Okay? All right. Good night, everybody. Go ahead and log out. I don't want to be rude and shut you off. So go ahead and log out. When you're all logged out, I'll shut down. All right. If you want to hang out, Yunming, for a couple of minutes, I will explain. Okay. All right, Yunmeng, does that make sense? They are in nature. That is how nature works. Period. That is not something we have control over. If I play a note C, and here's the string, and I cut the string in 1/2, okay, then I get C prime. It's the same note. It's exactly the same note, and that is how nature works. So there's nothing magic about it. There's nothing mathematical about it. Well, there is something magic about it because I think it's kind of incredible that it works that way in nature. But the fact is, Yunming, that this is how that works in the real world. And if you want to know, if you want a little deeper understanding, if I pluck this string, it vibrates. And it vibrates like this. And if you'll notice, the vibration point is right in the middle at 1/2. So what happens is this goes like this, and this is how the string vibrates, just like this. Okay? And it crosses right there. So you get two of the exact same waves as this wave. So that's why you get the same note. Okay? That's kind of the physics of it. I won't pretend to understand. But for some reason, when it splits exactly in half, that's the way it works. Okay? Are we good, Yunming? Now you can manipulate, you can mess with, you can add and subtract those ratios. Okay? That's what you do if you play the flute. Because when you play the flute, you put your finger on the different holes. So if we have a flute right here, and there are holes, right? And we're playing the flute. What happens is if you put your finger on these three right here, you're adding and subtracting ratios. So you make different notes because you're adding and subtracting ratios. Just like we did today in class. You took those ratios and you added and subtracted them. When you added and subtracted them, you got different notes. Okay? Does that help, Yunming? All right. Are we good? Good, good. All right. Good night, everybody. I'm going to shut down now. And we will see you on Monday. All right. Bye.